Hey, we're going to be talking about Math.random today. So if you have a gambling addiction, or maybe you really like Valorant skins, or like loot boxes, or I don't know, anything that that you like, pull the slot machine lever and give you something. Um, Pokemon card packs. This is the video for you. You can make your own slot machine with Math.random. So all you need to do is import the Math package. And you're going to say math.random, and that's it. That gives you a random number. Now, this random number is between 0 and 1. 0 is inclusive, and 1 is not inclusive. So it will give you any number from 0 to 0.9999999. And this is by design, and we'll see why in a second. So I'm just going to print out. Oh, and this is always a double, by the way, right? Because if it wasn't a double, if it was an integer, just get chopped off, right? I'm going to make a double variable. Double b equals math.random. I'm going to system out print line b. Let's see what we get. Oh, wow. Very small. Halfway. Yeah, we just keep getting random numbers, right? Pretty nice. Okay, but like, what if we want numbers bigger than 1? Or 1, or only whole numbers? How do we do that? Well, in Python, what you'd probably do is you put some numbers in here, right? You can't do that in Java. It just doesn't take any parameters. So instead, what you have to do is you actually have to do some math with this. So since your value that you're getting is between 0 and 1, there are a couple of ways that we can get around this. We can multiply the whole thing by some constant. And this will extend the range all the way up to whatever number we multiplied it by. So let's see. Yeah, so now our range is from 0 to 10, but not including 10, right? Because we didn't include 1. We stopped right before 1. We stopped right before 10. You still might be like, well, why would you do it like that, right? That doesn't quite make sense. Why wouldn't you just include 10? It has to do with probabilities. Getting a decimal number like this is a much, much, much higher probability than landing directly on 10. So they just cut it out. Or 1, I should say, not 10. 10 is because we've multiplied it. Just know that it's inclusive with 0 and exclusive with 1. Anyway, what if we want to get a whole number, right? Well, what we can do is we can actually cast this whole thing to something. What's a data type that you know that chops off the decimal and leaves you with only the whole number? That's right, char. Just kidding, it's an int. .4, right? Of course, I saved it back to a double, but I'll save it back to an int. Oh. So now the numbers that I get are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are all my possible values, right? 0 through 9, whole numbers. I can kind of see the use of this. I can kind of see how this could be useful. But what if I don't want 0? And what if I want to include 10? I could just add 1. There's all sorts of math you can do with this. Some key point that I do want to show you guys is the order that you do this casting. So notice how I wrapped this whole equation in parentheses. This is by design, right? Or this is on purpose. First, I want to get a random number between 0 and 1 and multiply it by 10. Then I want to chop off the decimal. If I do it like this, the rounding will only happen to the first random number, which is literally only a decimal. So if I were to do this, I would only get 0 because it just rounds down every time, and 0 times 10 is always 0. So hopefully that makes sense. And be careful with your casting and your parentheses and your math with this, because this is going to be very important in your classwork. Bye.